All right, so why? Why are certain acids stronger than others? Well, that has to do with their molecular structure. So an acid is H something, right? An H attack covalently bonded to something where that bond gets broken, right? The easier the bond is to break, the stronger the acid. All right, the major factors are the polarity of the bond and the strength of the bond. So very polar, weak bonds um, make you a strong acid. So as I go down group 7A, right, connecting H's to fluorine, chlorine, bromine, and iodine. As I go down group 7A, the atom size gets bigger and bigger and bigger, right? So the hydrogen gets further and further away from the nucleus. So the weakest acid is hydrofluoric acid with fluorine having the smallest radius, and the strongest acid is hydroiodic acid, which has the biggest radius, right? So the easiest bond to break here is the one between the hydrogen and the iodine, and the hardest one to break is between the hydrogen and the fluorine. As we go across the period, right? So where you connect H's to carbon, nitrogen, oxygen, and fluorine. It's about the polarity of the bond, right? So the most electronegative element in the second, across the second period is fluorine. All right, so the electrons get pulled more towards the fluorine and away from the hydrogen, and that makes the bond easier to break. So out of these acids, the hardest bond to break is the carbon-hydrogen bond, and the easiest one to break is the hydrogen-fluorine bond. So that makes hydrofluoric acid the strongest acid going across this group, right? Stronger than, easier to break the bond between hydrogen and fluorine than between hydrogen and oxygen, even harder to break it between hydrogen and nitrogen, and the hardest one to break is the one between hydrogen and carbon, weakest acid. So the more polar the bond, the weaker the bond, the easier it is to break. All right, so when we're dealing with oxyacids, right, it's an OH group connected to something. The acidity increases with the ability of that group to attract an electron toward itself. All right, so if I have a highly electronegative atom attached to that OH group, it's going to suck electrons away from that oxygen-hydrogen bond and make it easier to break. Also, an atom with a high oxidation state. So if I take a bunch of electrons away from the atom that's connected to that OH group, again, it's almost like a electron vacuum, right? This thing is hungry for electrons. So it's sucking the electrons away from that hydrogen-oxygen bond and making it easier to break. Again, making the bond more polar, right? So the electrons are more pulled towards the oxygen away from the hydrogen, making it easier to break. All right, so if we look at the Ka's of perchloric acids, the first ionization of sulfuric acid and nitric acid, the strongest one is perchloric acid, right? It has the biggest Ka, and uh, it's the one that, I mean, 10 to the 9, there is no perchloric acid or hydrogen, the hydrogen perchlorate when you put it into water. It totally breaks. All right, so if I'm comparing sulfuric acid to perchloric acid, you've got both things working for you with respect to the chlorine and the sulfur, right? So those OH groups of sulfuric acid are connected to a sulfur, which is less electronegative than the chlorine. The OH group connected to the chlorine is going to pull harder on the electrons and weaken that H bond. Not only that, but if you look at their oxidation states, the oxidation state of sulfur in sulfuric acid is +6, and in perchloric acid it's +7. So both things. Chlorine's more electronegative and it's more highly oxidized. So electrons being pulled in and away from that OH group. Comparing nitric acid, which is a strong acid, right? So that H is easy to break off, whereas with nitrous acid it's harder. And the reason is not the electronegativity of the atoms, because they're both those OH groups are connected to a nitrogen. So it's about the oxidation state of the nitrogen, right? +5 in nitric acid and only +3 in nitrous acid. So again, with nitric acid, it's like an electron void, right? The electrons being pulled towards the nitrogen because it's so hungry for electrons. So if we compare perchloric to chloric to chlorous to hypochlorous, again, it's the OH group is connected to that chlorine, so it's not about electronegativity, it's about oxidation state. So the oxidation state of chlorine and perchloric acid +7, in chloric acid it's +5, in chlorous acid it's +3, and in hypochlorous acid it's +1. So the easiest bond to break is the H in the OH group of perchloric acid. All right, and just a reminder, right, if we're matching up an OH group with a 1A or 2A metal, we just have a base, right? So we've got a polyatomic ion, hydroxide, and some sort of cation. So most hydroxides are insoluble, but the soluble ones are strong bases.